All right. So today's unit, Unit 3, Parent Functions and Transformations, starts with piecewise functions. Now, we're going to talk all about piecewise functions, and hopefully we'll explain it in a way that you can understand and that is not too complicated, because these really aren't very complicated. All right. So the question that we're going to answer is, what are piecewise functions? Now we're going to define piecewise functions specifically, and then we're going to start by evaluating them and then graphing them. But before I give you the official definition, piecewise has the word piece in it, which implies pieces, which implies more than one thing. And we're talking about functions. So more than one function contained in one overall function. So the way we define piecewise functions is two or more functions each with its own domain that make up one function. Two or more functions, each with its own domain, that make up one function. So this one function has pieces. Can y'all see that? Alright, now look at this first example, f of x. It says given f of x equals x squared minus 1 if x less than or equal or less than negative 2, and 5x plus 3 if x is greater than or equal to negative 2. And we want to find each value. So this one function, function f, has two pieces. Each of the pieces is its own function. Now what we would end up doing is graphing each of these functions based on what their domain is. Now, we always focus on domain in algebra. And there's a very simple reason for that. The domain is what determines the range. So you don't start with the range, you start with the domain. So everything comes from domain, the x values. Now when I'm evaluating this function f of negative 5 tells me that x is going to be negative 5. But the question is, which of these am I going to plug it into, or am I going to plug into both of them? Well, the answer is you're not going to plug into both. You're only going to plug into one of these. You're going to plug into one of these based on this x value and these domains. So, negative 5. So, f of negative 5 tells us that x is negative 5. Now, where does that negative 5 fit into these domains? In this one or this one? The top one, because negative 5 is less than negative 2. Because that's where it fits in, this is the function that we're going to use. So it's going to be parentheses, negative 5 squared minus 1. And then simplify it. Negative 5 squared is 25, minus 1 is 24. Alright, that was easy enough. Let's look at the next one. Negative 2. So where does negative 2 fit into these domains, Paige? Well, is negative 2 less than negative 2?
No, it's less or equal to negative 2.
Therefore, it would be this one. Because negative 2 is greater than or equal to negative 2. That's a true statement. So we would do the second equation, 5 times negative 2 plus 3, which simplifies to negative 10 plus 3, which is negative 7. Again, that was pretty simple, right? This one's going to be just as simple. We just have to choose which of these domains the 7 fits in. Would it be x less than, 7 less than negative 2, or 7 greater than or equal to negative 2?
7 greater or equal to?
Exactly. So 5 times 7 plus 3 will be 35 plus 3 is 38. Okay, so evaluating one of these functions, this is greater than or equal to, yes. If it points to the right, it's greater than. All right, look at the second one. This time, function g is made up of 3 pieces. In other words, 3 functions. Now, each of these functions has a domain attached to it, associated with it. So we look at these numbers to determine which domain they fit into. So where would the 2 fit in?
The bottom one?
The bottom one, greater than or equal to 1. So we would use the bottom function. So 2 times 2 cubed plus 9. And what does that give us?
That is 4 cubed. That is...
Well, it's not 4 cubed. I'm glad somebody said that. It's 2 cubed times 2.
So it's 8 times 2 is
16. Good. 16 plus 9 equals 25. Okay, so always do the exponent part first. Alright, look at negative 1. So where does negative 1 fit into these?
The second one?
In the second one, good, because between negative 4 and 1, we find negative 1. So we would do the second function. So negative parentheses, negative 1, in the parentheses, minus 1. We got lots of negatives and lots of 1s. So that's going to be 0, because negative 1, negative makes positive, and 1 minus 1 is 0. All right, let's do the negative 6. Where does it go? The bottom one, because negative 6, does it go in the bottom one?
No,
It goes in the top one. Negative 6 less than or equal to negative 4. So we use the top function. So 1/2 times negative 6 plus 3 also comes out to be 0. Okay, so because 1/2 of negative 6 is negative 3, and negative 3 plus 3 is 0.
Oh, okay.
Okay? All right, so evaluation of functions is easy, right? Nod your head that was easy, please, because that was. All right. Now, notice that in these problems, we had several different types of functions. We had a quadratic function, we had a linear function, we had 2 linear functions here, and a cubic function. We haven't talked about how to graph cubic functions and quadratic functions. We've only talked about how to graph linear functions so far. So guess what? When we have to graph these things, we're only going to be graphing linear functions. That's easy. That's super easy. So if you were to look at numbers 3, 4, and then 5, 6, 7, and 8, they're all linear. All the pieces are linear, which makes this easy on us. Now, this is when you need a pencil, because there's going to be some erasing going on. I wouldn't use a pen for these, because it's very easy. Well, for one thing, to start with, we're going to be drawing parts of the graph that we won't actually need. So we'll need to erase those. Alright, I'll explain that in just a second. You'll see. Alright, look at the first function here. This function has 2 pieces. The first piece is f of x equals x. That's our parent linear function. See over there on the wall, y equals x? It's the same thing. Alright, negative 2x plus 1 is another linear function. Notice the domain. The domain of the first function is all the x values less than or equal to negative 3. And the second domain is all the x values greater than negative 3. So we've got 2 parts of this graph. Part of the graph is going to be on the left side of negative 3, and part of the graph is going to be on the right side of negative 3. So what we need to do, because our domain involves a dividing line of negative 3, let's put a dotted line at negative 3x value. Just that step is very important. This dividing line that I call it a dividing line, boundary line if you want to call it that, this boundary line is going to make our lives easier. So if I've got two functions, I'm going to have two parts, right? One on each side of the boundary line. If I had three functions, how many parts of the graph would I have? Three parts of the graph, which means I'd have two boundary lines, right? Alright, so let's do this. Now, the first one, y equals x, or f of x equals x. What is my slope in this function? It's just 1 over 1. Good. What is my y-intercept? No, that's the domain. That's not the intercept. 0. Good, because it's really f of x equals x plus 0. So I'm going to put, to start with now, understand me, I'm going to put a 0 for my y-intercept. I'm graphing this line, but you'll see in just a minute we're going to erase some of it. And then my slope is 1, right? So up 1, right 1. So now you need your straight edge, and it needs to be something that is pretty straight, so you can draw a straight line. You need to draw this line like very lightly, because some of it will get erased. Okay, so there's my line. Y'all see that?
It's not.
Yeah?
How far one of your rules?
Okay. Okay, now, this line is covering the whole graph, but it's only supposed to be on the side where x is less than or equal to -3. Would that be on the left or the right of the dotted line?
Left.
It'll be on the left. So what part of this graph do I not need?
The right side?
The right side. So I'm going to erase everything to the right of that dotted line. Now, on the dotted line, where my line crosses the dotted line, I'm going to put either an open or a closed circle. Based on this symbol, would it be open or closed? It'll be closed. Very good. So right here is closed. And I'm going to put an arrowhead on the other end. So, we graphed the whole line to start with, but we didn't need the whole line. We only needed the part of the line that was to the left of that dotted line. And wherever it crosses the dotted line, you put your open or closed, based on what the symbol is. Alright, let's graph the second piece. So, we're going to go up 1 for our y-intercept. Then we're going to go down 2 to the right 1 and draw our dotted line. Draw our line, not dotted. And again, I'm going to go across the whole graph to start with, but then I'm going to erase some of it. Alright, so in this case, what part of this graph do I need to erase? The part on the left of the dotted line or the right? The part on the left. So I'm going to erase this part right here, but on the dotted line, am I going to have open or closed? Open. Right where it crosses. Open. And I'm going to put an arrowhead on my other end. So that looks goofy. It looks different. Okay? But it's only because it's two different functions graphed on the same grid based on domain. Now, it's asking us for the domain and the range. Remember, domain is x values. So, think about it this way. From this solid point to the left would be to -infinity, right? So I know it's going to go to the left forever, so I'm going to start with -infinity. Okay? So from -infinity to this solid point. Now, since this point is solid, I'm including the -3. And then it goes on forever to the right, starting at -3. So what does it go to? Infinity. I'm including all of the x values in this graph. There's no x values left out. Are there some y values left out? Not really. Well, the ones above this point, we'll see that just now. Alright, so for the range, you always do your lowest value first, always, for domain and range. So this thing goes down forever, right? So from -infinity up to this y value. What is that y value? 1, 2, 3, 4, 5, 6, 7. 7. Now, if it's open, what type of symbol am I going to use? Parentheses. For my interval notation, I will use parentheses because it's open, and open means it's not included, whereas the bracket means it is included. Okay, so this, that's a 7. Alright, let's do the next one. Hopefully this stuff will start to make sense. Alright, where am I going to put my dotted line? Negative 1. Okay, so I'm going to put a dotted line at negative 1. Be careful with it. Make it straight. Straight as you can. It doesn't have to be real dark. Jalen, open that door. Thank you, Coach. Appreciate that. Alright. Okay, so we got our dotted line. Now, this first graph has a y-intercept of negative 7, so let's do that. 1, 2, 3, 4, 5, 6, 7. And then slope of negative 3, but it's going to put me off the chart, so what would I do?
Up 3.
Up 3.
Right.
Left 1, right? Okay, now I'm going to draw my line. Remember, I want it to kind of cover the whole graph, because I just need to know, I need to have a clear view of what I'm going to erase. Can y'all see that line? It's kind of faint. Alright, now, what part of this line am I going to erase? Wait a second. The right side. Because this says this thing needs to be less than negative 1. Less is to the left, right? So I'm going to erase everything on the right of that dotted line. Now, will this be a open or closed circle on the dotted line?
Open.
It needs to be open, so I'm going to erase that and make it open. And put an arrowhead right here.
So do you have any more spare rulers?
I do. Gregory's kind of stingy sometimes. Alright. Okay, now look at the next equation. Negative 5. F of x equals negative 5. What type of line is it? Horizontal. So we need to go down to negative 5. 1, 2, 3, 4, 5. It's horizontal. So I'm just going to draw a horizontal line carefully at negative 5. Okay, and I need which part of that graph? The right side of that graph. So I'm going to erase the left side of the graph. And on the dotted line, is it going to be open or closed? Closed, because it's greater than or equal to. So there's my graph. It looks weird. It's weird because it's two different functions. Yes, sir?
How do you do it with horizontal?
Because f of x, which is like y, equal to a number is always horizontal. If it's x equals a number, it's vertical. Alright, so domain. Are there any x values that are left out in this graph?
No.
Nope, it covers all of them, because it goes from the dotted line to the left forever, from the dotted line to the right forever. Therefore, that's all of them. So we do negative infinity to infinity. And for the range, think about it. Is it going down forever? No. Where does it start? At negative 5. Now, is that negative 5 included?
Yes.
Yes, so it's bracket. Does it go up forever?
No. Yeah.
It does, but are all the y values included?
No.
Only the y values that are between, that are greater than, whatever this is, negative 4. I did this wrong for my previous class. I'll have to correct that. Greater than negative 4, and then just the negative 5. So when we do this, you know what? I don't even know if there's the best way to do it. I'm just going to say negative 5 to negative 5. That doesn't make much sense. That's probably not the right way to do it. Union negative 4 to infinity. That may not be the best way to do that, You know what? I'm just going to say -5. Instead of doing it like that. If it's just 1 point, because it's just one y value, it's just -5 union -4 to infinity. Because from -4 to infinity up is what we are dealing with. Alright. Let's take a look at one more of these on the video, for the video. Let's look at number 6. Let's skip 5 for a minute and look at 6. And I want to do 6 because it is 3. 6, just turn page. Alright. Okay, so look at the values that we've got. -5 and 1. So where do you think our dotted lines are going to go? -5 and 1. So understand, these are x values now. So go to the left -5 or to the left 5 and put a dotted line. And then go to 1 and put a dotted line. Remember, your dotted lines always are vertical at whatever the x values we're dealing with. So there are 3 parts to this graph. There's left, middle, and right. Normally, these functions are arranged in that order, left, middle, right, or left and right. So this top one, it just makes sense that that's the part that's going to go on the left. The middle one's going to go in the middle. The bottom one's going to go on the right. Okay? So this first function, g of x equals -1. What type of line is that? Horizontal at -1. So I'm going to go down 1, and I'm just going to draw a horizontal line. Now, I know that this is a horizontal line, and I know that this part has to be less than or equal to -5. Do I need to draw the whole line and then erase? Just draw it to the dotted line, and is it going to be solid or open? Solid. Okay, I didn't need to draw the whole line this time and then erase. I can see that it's only going to be on the left side of the left part of this graph. Alright, we're done with that one. Let's go to the next one. Now, this one is going to be in between -5 and 1. So, it's going to be touching both dotted lines. My line is -3 for the y-intercept and a slope of -1. So, down 1, right 1. And then I'm going to draw that line. Okay, so when I draw that, I'm just doing it in between the 2 dotted lines, right? So on the left part of this line, is it going to be less or open or closed? Open. It's going to be open because what is the first symbol right there? Less than. So it's going to be open. All right. On the right side, it's also less than. So what does it have to be? Open. So I'm going to erase the point and put open. You don't have to erase this point in the middle. It's just there. You don't. It's fine. I know it. That's just the point that we use to help us draw the line. You don't have to erase it. All right. Now we're done with the middle one. Okay, the last one. X greater than or equal to 1. So this is f of x, g of x equals 6. This is a horizontal line at 6. So go up 6 on the y-axis. I mean on the x-axis. Y-axis, sorry, what am I thinking? 1, 2, 3, 4, 5, 6. Alright, do I need to draw the whole thing?
No.
No, just from the dotted line to the right, and it's solid. So we've got 3 different parts, 3 different functions graphed on the same grid based on different domains. Pieces. 1 piece, 2 piece, 3 piece. This is a 3-piece chicken box. Alright. For the domain, this thing goes to the left forever, right? And then it runs into this one, but it's like these things overlap. So there's no space in the x values. So it just keeps going, and then these overlap. There's no space in the x values, and it goes on forever. So do I miss or leave out any x values? No. So, negative infinity to infinity. I know those look like slanted 8s, but they're supposed to be infinity. Alright. Now, for the range, the lowest range value is this value right here, which is what? Negative 4, right? But am I including the negative 4? No, I'm not. I'm not including it. Alright? So it goes from negative 4 up to, what is this value right here? 1. Also not including it. It skips some and then starts over, so I have to do the union, and then it starts over at 6. And does it go higher than 6? No, so just union 6. That wasn't hard. There's no bracket, because it's just one number. Okay?
We'll put brackets on the top, though.
No, because these are open. If it's open, it's just parentheses. Alright, I'm going to stop the video there. We're going to do some more practice off the video.